Now we will look at determining if a function is even or odd using the symmetry of the graph, okay? Okay, so determine if this function f, this is the graph of f down here, determine if it's even, odd, or neither. So we need to locate x and negative x and then compare their outputs. If their outputs are equal, then the function's even. If x and negative x have opposite outputs, then it's odd. If neither one of those is true, then it's neither even nor odd. So let's locate some random x value like right here. Then of course negative x would be over here. Hope you understand the relationship between x and negative x. And again, this is my picture's not perfect, but you get the idea. The output for x would be like this y value up here. The output for negative x would be this y value up here. And you can see that those 2 points have the same y value. Same output. Similarly, this x has the same output as its opposite, negative x, over here. So you can start to see that no matter what x you choose, negative x is going to have the same output because this graph is what we call symmetric over the y-axis. It's a mirror image of itself over the y-axis. Every point has a mirror image across the y-axis. That is precisely the same thing as being even. So even means symmetric over the y-axis. So this function, f, is even. Now, we might as well investigate if it's odd. Clearly it can be even and odd, but let's take a look. If I look at x and negative x, let's get some more room here for a moment. X and negative x. Well, the opposite, for it to be odd, negative x would have to have the opposite output of this, which would be multiplied by the y. The output would be multiplied by negative 1, so we'd have to have an output down here. Well, we clearly don't. This is what would happen if f were odd. The mirror image of this point wouldn't be over here, it'd be reflected over the y and the x. Another way we say that is it's reflected over the origin. Okay, so let's look at an example of a function that is that is odd using the property of an odd function. Okay? And as we just said, if it's going to be odd, it's symmetric over the origin, or across the origin. Okay? So this function will be odd. See if you can verify why. You may want to pause this and see if you can understand. I'm going to move forward though. Let's look at x, some x value. Its output is right here. Negative x would be over here. Its output is here. Well, the output of x is this positive y value. The output of negative x is this negative y value. And we can see that they're equal, but one's positive and one's negative. So the outputs for x and negative x are opposites. And you may want to investigate, is that true for any x? We could look at, let's look at this x here. Let's use a different color though. Let's use green. For this x, our output is up here. For negative x, that would be like right there. The output would be this thing. And you can see in this case as well that the output of this x is this positive y value. The output of the opposite of that is this negative y value, and they're equal but opposite. Okay, so yes, this function f is an odd function. Most functions are not even or odd, okay? But they're special cases. They have some nice properties, so we're looking at them here. Okay, so here's a very common function, but it's not even or odd, and let's take a look at y. If we choose x, some x value, its output is this y value. Negative x, well, may be confusing, but negative x doesn't even have an output. So clearly, for a function to be even or odd, x and negative x both have to have outputs. They both have to be in the domain of the function. Negative x, no output at all. So clearly the output of negative x does not equal the output of x. Clearly the output of negative x is not the opposite of the output of x. So this is, and all it took was a single point to see that. So this is neither even nor odd. Okay? All right, I hope that helps you out. Good luck.